Hi, I'll be giving a presentation about optimizing the network, electricity network that composed of diesel gas generation, electricity from storage unit, and the solar power generation. So the objective of the project is to minimize the total cost of the full generation to meet the electrical load. Um, this is the network that we'll be looking at. The parameters that we have are the maximum power output of each of the generation and the maximum power demand from the load side. The system detail is that, as we stated, solar generation, storage generation, and diesel generation will have to meet the consumption of the load. The variables that we can control are the storage and diesel. The solar and load are going to be provided as real-time measurement profiles. It'll be divided into 24-hour kind of segment to have a detailed view. And then in order to minimize the cost, since the solar power we're going to assume as free resource, will be subtracting the consumption of load from to the generation of solar. So here's the solar generation profile that we'll be using. At hour about 2:30, it'll be peaking, and then here's the load profile that we'll be using the earlier in the morning, and no one's going to awake, so very low demand here, and then we're going to see the peak at around hour 20 when everybody comes home. And then the system detail, we're going to have three states for this system. The first one is going to be the ESS, which is the ratio of residual energy to the total battery capacity. So ESS itself is going to be the kilowatt hour, the full capacity of the battery. And this thing is going to be actually the ratio that'll change. So ESS per hour, the delta is going to be the ESS per hour, which is given. These parameters are given as well. We're using a more kind of typical residential battery storage unit that you can find. And the second and third states that we'll be looking at is the PSS, which is the immediate power output of the storage unit, and then the PD is going to be the immediate power output of the diesel. These are very similar in terms of their dynamics of behavior, since they are kind of on-demand generation that you can control immediately. The tau here, the time constant, is going to be the time that the generation will need to reach its steady state, which in the case of storage system, it's going to be 0.1 second, and the diesel generation is going to be 0.4 seconds. So the control strategy, we'll be using model predictive control, which will be fed the state information from the electrical system here, which is going to be the summation that we saw earlier in the slides, and then the MPC controller is going to bring the output U, which is the stacked command of the U storage system, so UESS, and then UD, which is going to be the control command for the diesel generation. The mathematical kind of representation is shown here. The W's here are the tracking rates. These are just parameters that I had to kind of tweak in order to run the simulation smoothly. The X is going to be the stacked variable of ESS, PSS, and PD. And the upper and lower limits here were the numbers that were shown in the graph earlier on. And the V variable is used in order to kind of turn on and off the state, basically alternate between the states of charging and discharging of the storage system. The logic of the logic of V, which is the prediction of charge or discharge, is determined by the USS, which is the current control command. So when the USS is greater than 0, we're going to assume that this state system is discharging. So the result is shown here. This is the reference load, which is the subtraction between this graph and this graph. So you can see the peak is kind of more pronounced after subtracting the solar behavior, generation behavior. And then the state, we can see that the ESS, the ratio of how much charge is remained in the battery, is going down over time, which makes sense because we're trying to prioritize the usage of battery before anything else. So it'll be pretty much depleted around hour 20 when the load is peaked. And then here we see the power output of the storage system as well, which will try to follow the slope, the biggest kind of change of the load demand, which is clearly shown here as kind of expected behavior. And then the PD, the power output from diesel power, is gonna not kick on until the load is up to certain demand point. Hence why it had no output basically until hour 5 when it's still kind of when it starts to climb up. The control command should follow exactly the same as the behavior of the power. We can see from the graph number 1 that the storage system is kind of mimicking its own power behavior, and so does the diesel. And then the mode, which is the V variable, it shows when the solar system was charging, discharging, charging, and discharging. And then the cost obviously goes up as the iteration goes up as well. And here are the references of the simulation. Thank you.